All right, so this is Chapter 15, Section 2, the properties of matter. And so we're going to talk about physical properties. Physical properties are properties that you can observe without basically changing the identity of the object. So I think of these as truly, first of all, like physical properties. So like you look at an object, what do you see? What is its color? What is its shape? What is its size? What are its true physical attributes? What does it look like? So if I look at a chemical, I look at a substance, I look at a mixture, what does it look like? What is its physical properties? And then physical properties, though, can also be things that you might look up in charts, like what is its density? What's its melting point? What's its freezing point? What's its boiling point? What's its solubility? What is it, anything that you might look up from a chart, basically, those are all physical properties. We can separate substances based on its physical properties. Is it a solid? Is it a liquid? Is it a gas? So we can separate things based on if it's a solid, liquid, or gas. We can filter things. We can do all those kinds of things. So that's physical properties. And separating substances by physical properties are called physical changes. A change in the size, shape, or state of matter is a physical change. So the key with a physical change is that the identity of the element or the compound does not change. You have what you started with. So, for example, ice melts. We'll see a lot of that here lately. Ice melts. So I take an ice cube, I heat it up, it becomes liquid water. Or even if I heat it up enough, it becomes gas. Is it still water? Yeah. So I haven't changed the true components of what makes that up. I've simply changed phases. So that's an example of a physical change. Keep in mind that color changes can happen in physical changes. So just because you necessarily see a color change doesn't mean that it's not a physical change happening. I put, for example, down here that when you heat iron up, it does turn red first. And so just because it's turning a color doesn't necessarily mean that a physical change is not happening. When you heat metals up, they a lot of times turn color, they melt, and then even like iron, for example, sometimes turns white. Okay, so just keep in mind that you have to ask yourself, though, is what you have still what you have? And if you can answer the answer yes, then a physical change happened. Distillation is a process of using boiling points to separate mixtures. So this would be an example of a physical change. So basically, you have a little apparatus over here. You could actually do this. It doesn't have to necessarily be, a lot of times you think of liquids, but I've actually done this with Kool-Aid, where I could get the Kool-Aid packet back in, separated from the Kool-Aid packet to the water, where you just basically, one thing is going to boil it before the other. And so what happens is that the water would boil first. It's going to go up here and into this flask, and then eventually you've got cold water running through here, and it's going to cool off, and all your water will come over here. And so it basically recondenses into vapor, leaving you the Kool-Aid over here in your original sample and the water in the other side. And that's a process called distillation. All right, then we have these things called chemical properties. And a chemical property is a characteristic of a substance that indicates if it'll undergo a chemical change. Basically, will it react or won't it react? If you take an object and mix it with sodium, will it react and make something new? If it is something flammable, that's one of the big ones. Will it catch on fire or not? Big thing is with chemical properties simply, is it going to react with something or is it going to catch on fire? Those are the big two. So then that's where we get these chemical changes, or also called chemical reactions. And that's where we have something changing from one substance into another. And of course, the big thing here is that something new is formed. Something new can be gases, it can be water, it can be a totally new substance. An example I put here is that when your car rusts, rust is a new substance. We have something new. Iron reacts with the oxygen and water in the environment to produce rust. Okay? Clues that you have a chemical reaction happening. Heat is produced or something's cooling. You have bubbles, such as a gas is being produced. Solids or liquids. Solids in liquids, meaning that you have what's called a precipitate being formed. There's a chunky stuff being produced. Those are all good indicators that a precipitate is, or that a chemical change is happening. The key with any chemical reaction, though, is that the law of conservation of mass has to occur. And what that means is that the masses of substances that start have to be there when you end. So no mass is lost or gained during a chemical reaction. So for example, if you start with 5 grams at the beginning, you better have 5 grams at the end. Granted, you may not have the same things when you start and end, meaning that you may have had water in the beginning part of the reaction. You may not end up with water at the end of the reaction. And we'll talk more about reactions later, but this is just kind of the general gist. And that's kind of the end of chapter 15.